Let's remind ourselves about whole body listening. Cooper, we're ready to start, my dear. Ears are listening. Your brain is thinking about what is being said, right? What Mrs. Alvin is saying. Eyes are looking up here. Mouth is quiet, Finn. Mouth is quiet. Hands and feet are down and still. And we are ready for math. Thank you. All right. So today you're going to find your math lesson in math. Today is lesson 5. I forgive you, even if you didn't do it. All right, so today is a lesson with lots of different parts. One of those is looking at comparison problems with extra information. That's one part of our learning target. The other learning target is looking at problems with hidden information. And the third, Sawyer, is not enough information. Do you guys remember any of that from last year? Does that ring a bell? Not really? Okay. So the reason we're going to do this is because in real life, we'll have problems like this. You'll be able to recognize the problem. If the problem has extra information, you'll recognize if there's hidden, somebody hid it, or if there's not enough. It's kind of like yesterday's lesson in the fact that we were misled, right? They took us in the wrong direction and we still had to outmaster them. We're kind of doing the same thing today. We're not going to be tricked, right? Because we're thinkers. We visualize. We're problem solvers. All right, let's warm up those brains. Mrs. Harrison had 4 boxes of pencils with 6 in each. She shared them equally with 8 students. How many pencils did each student get? Show me on your fingers how many parts you think this problem has. How many parts or steps? Maybe we should call them steps, be better. What do you think, Henrik? How many steps is this going to take us? You're right. Henrik says 2. If you put up 2, you are right. So go ahead and see. Where do you think the first step ends? After which word, Robert? After which word could I draw a line to separate my first step from my second step? Very good. Between each and she. If I were to draw a line here, I would know this is my first step. I'm thinking of a question, right? How many? Mrs. Harrison had 4 boxes of pencils with 6 in each. I want to know how many pencils does she have in all? What does she have? How many pencils does she have? That's what I need to know first. That's my first step question to answer. Then I'm going to look at my second step. She shared them equally with 8 students. I can't solve this until I know how many pencils she has. Go ahead and start solving it. Figure it out. Write it down. Write your equations. Draw a picture. Do something to show me you are trying. So how are you going to figure out how many in each? There's 4 boxes. boxes of pencils with 6 in each. Draw a picture. Draw your 4 boxes with 6 in each. Good job. I see Lucas knows what to do. He's got the first step equation. Now, you don't know the product. You got to do something, right? Use these. Draw a picture. You can figure it out. Use your strategy. Yeah. Drop on that number. And then drop on that. Look at that down. Retake it. Try again. Neither one of those are going to get you the right answer. You reflect. It won't make sense, I bet. Reflect and see what you think. No. Guys, I'm going to encourage everyone to draw a picture. I'm going to draw a picture too because some of you have very interesting equations that would not match this at all. Watch what this looks like when you visualize or draw a picture. If Mrs. Harrison has 4 boxes of pencils, look, Henrik, 1, 2, 3. Those are her 4 boxes of pencils. How many are in each? Look, 1 pencil, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. I'm asking you, how many pencils does she have in all first? Can I get that from subtracting? No. That's what you got to figure out first. Some of you, Charlie, did you redo it? Henrik, redo it. I'm just trying to guide some of you in your thinking. Now that might be the first step. Are you subtracting and getting 2? 6 minus 4 is 2, but are we subtracting? All right, Astria, what do you think I'm going to do to find out how many pencils Mrs. Harrison has?
Count how many pencils are in each box.
Okay, I could count them because I drew a picture. I'll go ahead and count them. Count with me. Ready? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 20, 24. We have 24 pencils, but is that the only way I could have figured out how many pencils Mrs. Harrison had? Sunny, did you do it a different way?
I did 6 plus 12, and 12 plus 12.
Okay, so she knew 6 plus 6 is 12. And because she knew this was 6 and this is 6, that was also 12. If you add 12 plus 12, you would get 24. Excellent. Did anyone do something different? Marin?
I did 4 times 6, or 4 times 6 is 24.
4 times 6 equals
24.
That's correct, but I was hoping we would use this equation because in 3rd grade, what have we focused on? Multiplication being repeated addition. So by now, we should be seeing that connection and being more efficient, right? And using that. If you didn't, that's okay. This is where you're at, and that's fine. We hopefully will get there by the end of the year, right? Where we see, oh, I could do 6 plus 6 plus 6 plus 6, but boy, that takes a while. 4 groups of 6 is 24. 4 times 6 is 24. Finn, you said we're not done. How do you know?
shared equally with each student.
Okay, so Finn is saying we're not done. It says we want to know how many pencils each student got. That's how many she has. That's the total. So now we want to know if she shared them equally. And Finn is saying because of those words, we know she's doing what? What's the operation, Finn? Stay with me, bud. I have 24. What operation am I going to use to find out how many of those, how many pencils each student got? What am I going to do? Divide. 24 divided by 8. How can I figure that out, Charlie Carr? How can I figure out how many 8s are in 24? Okay, he says that we're going to count by 8s till we get to 24. Let's do it. Ready? 8, 16, 24. What did we get? 3. 24 divided by 8 is 3. How many pencils did each student get? 3 pencils. Thank you, Mrs. Harrison, for helping us warm up our math brains today with a 2-step word problem. Well done, you guys. Oh, I bet you did.
I super love that the picture you drew was something easy and something I could have handled.
Oh, good. All right, you guys. I am looking for some thinkers on our next 3-act task. You should be getting better at these. So I want you to be writing down your noticings and your wonders. All right, remember the 3-act tasks? The first act is just what do you notice? What do you wonder? All right, so here, this is called the naughty rope, and not naughty like naughty bad, naughty like a knot in your shoes. All right, here we go. I'm trying to make it bigger for you. I just expanded it, I thought. Yeah, I did good. You know what? I need to go back for a minute. I just want to make sure I didn't do the wrong. When I expanded it, I want to make sure I didn't go to the wrong. Oh, it's Act 1. Okay, good. I get worried that I might give it away. Here we go. Oh. All right. Oh. Okay, that was Act 1. What do you notice? What are you wondering? Write it down before you share. I'll play it one more time while you are writing. Oops, wrong one. How does things like that happen? That does look fun, doesn't it?
Can we do that one tomorrow? They like pour something into it and the liquid just like disappears.
Pretty cool. All right, this is, so Mrs. Harrison and I noticed yesterday that some of you aren't writing anything down. So to be a mathematician, you do have to record your noticings and your wondering. That means that you need to be able to write, I notice, I wonder. So today I'm going to model that for you because I think some of us are struggling with that. And I realize that I have you're not modeling it, and that might help you. But some of you might be able to do that without my modeling. So guys, should I hear voices right now? Nope, this is thinking time. Yeah, sorry. Hey guys, please show me whole body listening and be polite, please. All right, so we're gonna go ahead. What did you notice? What are you wondering? Haley Booker, what did you notice or what are you wondering?
Why is it called the naughty rope?
Okay, she is wondering. So if I am recording this, she would be writing with a capital letter. Why is it called
Was this filmed here?
the naughty rope? So that's Haley Booker. All right, Bird, what are you wondering or what did you notice?
What I'm wondering is why there is a rope. Why is it showing a rope?
Why is it showing? Think like a mathematician. All right. Elena Ba, noticings or wonderings?
I noticed at the end of the video, the rope made like a little hill.
I noticed that, what was it? They
At the end of the video, there was like a little rope kind of made a hill.
made a
It was like
hill? Okay, sorry, thank you. I noticed that the rope made a hill. Okay, so this is what I'm talking about, recording your thinking. You should be writing in a complete sentence. You should have a capital at the beginning, either a question mark or a period. But when I hear from Mrs. Harrison, she walked around, nobody wrote anything. I was like, what? Ah! I felt like I wasn't doing my job very well. So I hope this helps you. We are looking for sentences, something that you notice or wonder. Yes, Lennox.
I think that there was 3.
Okay, what did you notice?
I noticed that there was 3 knots.
So you would write in your spiral, I noticed that there were 3 knots. Right? Okay, Miss Lalamars.
I noticed that it was a long rope and she did 3 knots.
So Lila said, I noticed that it was a long rope and it had 3 knots. Okay, so that should give you the idea. I would love to hear from somebody at home what you noticed or what you are wondering. Let me see. Ben, can you unmute and share?
I'm wondering how long the rope is.
Okay, so he is wondering. I love that, Ben. How long is that rope? That's a great mathematical wondering. So I wonder. Okay. How long the rope is. Excellent, Ben. All right, guys, so that's what we mean by sharing your thinking, noticings and wonderings. I'm gonna stop sharing for a minute, see if I can get out of that. I did not get to everybody, I apologize. We are going to go ahead and watch this Well, first I'm going to ask you, see if I can get back. Let's get rid of this. That was our first text. So I am going to ask you to make an estimate. How many knots will fit on the rope? So this is what I want you to write. How many knots will fit on the rope? Your estimate. Now remember, make one that you know is too high. So for example, my estimate that's too high, I'm going to say 50. That's a good one. 50 would be too high, right? If I said 4, that would be too low. So our estimates should be somewhere between 4 and 50 to be reasonable. That's the point in doing a high and low, so that you don't do something that isn't reasonable, okay? So go ahead and write down your too high estimate, your too low, and how many knots you think would be, you'd be able to fit on the rope. So again, you're supposed to be recording this. Did you have a pencil? I'm gonna, yeah, take this. We don't really need this in math. I like how Marin put an H by her high estimate, so I know it's her high, an L by her low. Why don't you put a circle around the number that you think it actually is? Thank you. Okay, I'm going to pick a few names out of my handy dandy can, and we will see what some of our estimates are. Paxton, what do you think? What is your estimate of how many knots will fit on the rope? 15? All right, does anyone agree with him? Elena, how many? 35. Does anyone agree with Elena? Serne? 33, so you're close to Elena. Henry, what about you? Henry Morgan, can you unmute and share your thinking? How many knots do you think will fit on the rope? We can't hear you, buddy. You need to hit unmute.
25.
25. Okay, Katie, what about you? Thank you, Henry.
I think maybe 13.
13. All right. Reese, what about you? Okay, maybe not Reese. Abby, how about you?
Abby and chat said 40.
40. Okay. All right. Now I am going to answer Ben's question. You ready? Ben, you had a brilliant question. You said, I wonder what the length of the rope is. The length of the rope with no knots is, it looks like, let's get it bigger. 44 inches. So now you know the length of the rope with no knots is 44 inches. Write that down. This is information to help you make an educated estimate, right? So if you know the length of the rope without any knots is 44 inches, you need to know something else. We want to know the length of the rope with one knot. Watch this. Once he put one knot in it, now what is the length? 40 inches. So if the length of the rope is 44 inches, and when you tie one knot in it, it's 40 inches. Do some math. See if you can figure out how many knots we can fit on the rope. Now that you know that. Katie? Did you have a question?
My estimate to 11.
Oh, you changed your estimate to 11. Excellent. Can you tell me why?
I saw how long it was with one knot in it, and I kind of counted in my head to see if it would be 11, and I thought it would be 11.
So you did some counting. Okay. Can you draw a picture, some of you, if you're not sure? What did you count by, Katie? You said you did some counting. I'm so curious. Do you know? Like, how many of you figured out how many inches one knot took up? Did anybody figure that out? Paxton, what did you think about how many inches one knot took? He says one knot took 4 inches. Is that what you found, Katie? Give me a thumbs up if that's true.
That's what I found.
Okay, that's what she found too. So if you know one knot takes 4 inches and there's 44 inches on the rope, that gives you some information. Does anyone want to share a different estimate like Katie did? Cooper, what did you change your estimate to? 11. What about you, Charlie?
I changed mine
To
to
12. Did anyone else change theirs? Yeah.
I changed mine to
18. How about you, Madison? 10. Lila Maris.
I changed mine to 11 because I counted 4 to 44 and I got 11 numbers.
Okay. She changed hers to 11. What about you, Robert?
If one knot took away 44 divided by 4 equals, well, just 40 divided by 4 would equal 10. So 1 more 4 equals 11.
So that's why you think you would change your estimate to 11? What about you? That's a great explanation.
I changed mine to 11 because I know that 4 times 9 is 36, and then I added a few more, and then I got to 11, and then 11 times 4 equals 44.
I don't know about you, Mrs. Harrison, but I'm impressed with this thinking. What are you thinking, Josh?
I'm thinking 11 because 44 divided by 4 is 11.
Okay, I got a lot of different estimates. Did anybody keep theirs the same with that information? Raise your hand if you kept your estimate the same. All right, let's see how we do. Here's Act 3. Our second act was the information. Check your thinking. Oh boy. Should I move him? Yeah. Hey, Ryder. Oh, look at Katie celebrating. Nice job. All right, boys and girls, you should have gotten 11 because 44 divided by 4 is 11, or 4 times 11 is 44. So great job. We will keep doing 3-act tasks because what's great about it is you guys really show off your thinking. It makes me so proud of you because you do understand these concepts. Quick. Today, we just want to remember when we are multiplying, we don't know the total. Just like today with Mrs. Harrison's pencil. Did I know how many she had? Did I know? No, I had to do repeated addition or equal groups to find out. And with division, finally, we knew how many pencils Mrs. Harrison had, and she was giving an equal amount to 8 students. We knew the total. We were putting them in equal groups. That's division. So Charlie, Henrik, pay attention. The difference is with addition, some of you were doing subtraction and addition for multiplication and division today. So let's just remember, with addition, just like multiplication, you are looking for a total because some of you added, but you're adding different numbers. You're not doing repeated addition, right? With subtraction, you're getting rid of it. Someone's eating it, right? I ate the cookies, or I gave them away, or I donated them, or I spent it. So think about that as we problem solve today. We are not going to do all of these problems because we have quite a few pages. Start on 277. This one is extra information. What is the word, whoopsie, what does the word extra mean? Sawyer, what do you think extra means? If I have extra pencils, what does that mean? Only Sawyer, please. So he said if everybody has pencils and there's 4 more left, that's called extra. Do you need those extra 4 pencils if everybody has one? No, they're extra. If I were to bring cookies to the teacher's lounge and everybody got one, and there were still 5 left for me to take home at the end of the day, those are extra. I don't really need them, but I've got them. So these problems have extra information. We don't need it, but it's there. And sometimes Mrs. Harrison and I are really good at this. We are very detailed people, and when we talk, we like to give you all the information because that's kind of a teacher thing, right? But you don't always need to know everything, all those details to get the main idea or to get the answer. So we're going to cross it out so it doesn't mess with our thinking. You ready? Watch how I do it. I'll do it, we'll do it, and you'll do one. And then we'll move on to the next kind, okay? We're going to zip through these today. Emma solved 9 math problems and answered 7 reading questions. Her sister solved 8 math problems. Now, I want you to take your pencil and I want you to underline what they're asking us. What are they asking us? How many math problems did they solve in all? Does it say anything about reading? No. Do I need to know about the reading? No. Guess what I'm going to do? Cross it out. I'm going to cross it out, and so are you. What? I think I've got a loose connection. All right. So where it says Emma solved 9 math problems, do I need that? Yes. I still want that. And answered 7 reading questions. No, I don't want that. Get rid of it. Cross it out. You cross it out right now. is extra. Don't need it. Throw it out. So that you can't see it. Actually cross it out. Now I've got that her sister solved 8 math problems. Do I need to know that? Yes. So, Madison, if Emma solved 9 math problems and her sister solved 8 math problems, and I want to know how many math problems they solved in all, what operation am I going to use? Yes, good, which means what? Can you say it? To add. So all I have to do is say 9 plus 8 equals, and I'm going to do a little m, because I just feel like throwing a variable in there for the math problems. Go ahead and solve it. 9 plus 8. Henrik, solve it. Write it down. Let's see it. Did you cross out the extra information? No. Pay attention. Let's get going, guys. We're crossing out extra information. We're writing equations. Did you cross it out? Can I see an equation? Please follow directions, okay? Yay, good job following directions. Charlie followed directions. You don't want to pass out everything, just the stuff you don't need. Thank you for following directions, Cooper. See if you can label your answer. What is your unit? What are we talking about? Apples, pizza? What are we talking about? Math problems. Go and write it. Good job, Sawyer, following directions. You should do what I'm doing with you. On your paper. Okay, so you can copy out. Okay. Here we go. Good. That's your equation. All right. Microphone answer. What's 9 plus 8? 17. M equals 17. 17 math problems. Thumbs up at home if you followed along and you got the same answer. Gavin, how'd you do? My microphone has died. Oh, now it's working. It goes on and off. Can you hear me, Gavin? How'd you do? Thumbs up? Awesome. All right, let's do this one together. Lila Fitz, you ready? Mm-hmm. We're going to do this together. Mark had 6 shirts and 5 pairs of pants. Today, his aunt gave him 4 more shirts and another pair of pants. How many shirts does he have now? What's the extra information that we don't need? Pants. I'm letting Lila do it. Pants? Yeah, we don't need to know how many pants because what is it asking about? Shorts. Okay, so let's get rid of the 5 pairs of pants and another pair of pants. Go ahead and cross out that extra information. We don't need it. It's silly. It's going to mess with my head. Okay, so Lila, if Mark had 6 shirts and then his aunt gave him 4 more, what operation is that? Addition, subtraction, multiplication, or division? If I have 6, yeah, because I have 6 and I'm getting more, right? I'm trying to find a total. So 6 plus 4. What is 6 plus 4? Microphone answer. 10 shirts. All right, now you guys are going to do the third one, and then we're going to move on. A parking lot had 179 cars and 95 trucks. Then 85 cars left the lot. How many cars are in the parking lot now? First, find your extra information, Henrik, and cross it out. Then solve the problem. Go for it. Go ahead and solve it, then. Can I see? I don't see any. I don't see that you passed down the extra information. Don't pass it out. Great. So what is it ask? Okay, so what can we get rid of that is confusing? You just want to know about the cars. So what is up to that we don't want to know what we cross out first? We want to know about cars, right? What is the confusing part? Because this is how many cars. So what numbers have cars? Underline, circle the numbers that say cars. What's the number? So circle 85 Is that a car? That's not a car. What's the number that was cars? Now, what number is confusing? What's this happening?
No, it's 260.
What? What's the whole problem with that? Right. Anything extra? We don't need to know that? And what is it? That's really, that's what crossing. Do you have any information? No, you do. That's how you know how many are left. You know how many you started with. Information is not needed there. Ah, very good. Because? Very good. Did you guys decide to cross out? All right. All right, Sawyer is going to lead us in this one. All right, Sawyer, let's check our work. A parking lot had 179 cars and 95 trucks. Then 85 cars left the lot. How many cars are in the parking lot now? What do we need to do, Sawyer, to solve this? What do we need to get rid of that's not needed, that's extra? Right. Why are we getting rid of 95 trucks? It's not about trucks. It's about what? Cars. What operation are we going to use? That's not what you had. We would subtract. Why would we subtract?
Because it says 85 cars left.
They left the parking lot. You should subtract. Okay, Sawyer, how do I do this?
So you cross out the 9?
Well, 9's bigger than 5. If I have 9 apples, can I take 5 away? So do I need to cross anything out?
So that's 4.
Yeah, 9 minus 5 is 4.
So when you cross out the 7?
I don't want to cross out the 7. 7 minus 8 I can't do. So I cross out the 1, make it a 0, then I can add that 1. Can I do 17 minus 8? What's 17 minus 8? 8 in your head. Everyone count with me. 8, 9, 10, 11, 12, 13, 14, Henrik, 15, 16, 17. Stop what you're doing and focus. What's the answer? 90. Do you have that written? Bring your stuff and I want you to sit right here by me. All right, 94, what is our unit? 94 what? Microphone answer? Cars. All right, we are going to move on to the next type of word problem. These are not problems with extra information, but instead, these problems have hidden information. How many of you have ever played hide and seek? Oh my gosh, one of my favorite games. You should try hide and seek in the dark. That's what we do as my kids got older. Oh, it's so fun. And if you're scared, you could maybe ask for a flashlight. But we played hide and seek in the dark with my brother and his wife and all the teenagers, literally, on Thanksgiving. It was so much fun. We never laughed so hard in my life. We also, yeah. So that things are hidden. My husband could not be found. We found him in bed sleeping. Naughty, naughty. That's not how you play hide and seek. So here's why I say that. Sometimes things are hidden from us. We don't know what they are. Robert, not safe. You don't, oh, he doesn't get it. That's different. So in a word problem, it's not a person hiding. It's a word that you have to convert into a number. So for example, and we're going to circle the hidden information. Look at the first problem, number 6. Samuel had 16 horseshoes in the shed yesterday. Today he put a new set of horseshoes on his horse, Betsy. How many horseshoes are left in the shed? So the hidden information is actually horseshoes, because I need to know how many shoes a horse wears. And I was hoping Marin would be here because she's my horse girl. Are you a horse girl?
Me too.
Awesome. Perfect. So can you help me with this? Let's circle this hidden information. Because horseshoes come in a set. So even set would be like a hidden word. What does set stand for? If they're horseshoes, what do you think, horse people? What number would that bring to mind?
4.
There's 4 horseshoes, right? On each horse. I can't draw a horse. If I did, I would, but you can picture those are a horse's feet. And you know how they have like that little, like a U for a horseshoe, right? So horses have 4 legs, therefore 4 feet, and we need to know that. If Samuel had 16 horseshoes in the shed yesterday, and he put a new set of horseshoes on his horse Betsy, how many horseshoes are left? So I know I've got 16, and this word set means 4, and he put them on. We want to know how many are left. So that tells me I'm going to what? Charlie knows it. He's bouncing. Subtract. I'm going to take 4 of those horseshoes away because a set is what, right?
A set is like the same, like a Lego set or something with many different pieces that you fill.
But what does set represent here in this word problem? What number? 4, right? Because on a horse, a set of horseshoes for a horse is 4. Do you see how that was hidden? And 16 minus 4 is 12. So I would say I have 12 horseshoes left. All right, let's try more hidden information. Maya's going on a vacation with her family for a week and 3 days. How many days will she be on vacation? A week and 3 days. But no, that's different. No. Is Abby here?
She's on Zoom.
Abby, what is the hidden information?
The hidden information
What word
is
represents a number? We have a word in there that represents a number that we need to know.
I'm trying to look for it.
All right, I'm gonna let Lennox help you out. Lennox.
I think it is a week.
He says it's a week. Do you agree, Abby?
Yeah, I was looking for like some or something like that.
Oh, like keywords. Okay, we're looking for hidden information, which is really words that represent a number. So Lennox, why did you say week is hidden? What do you know about the word week?
I know that a week is 7 days.
So he's saying a week equals 7 days. Do we need to know that to solve this problem?
Yeah.
Yes, so Max, what would the equation be?
It would be 10 plus 3.
Well, let's read it again. Maya's going on a vacation with her family for a week and 3 days. So how many days are in a week? 7. And then what operation should I use?
Addition.
And what number am I adding?
3.
Okay, how did you know we were gonna add?
Because I know a week is 7 days.
Okay, he says a week is 7 days.
I can just look at the calendar. I can just count 1, 2, 3, 4, 5, 6, 7, and then set 3 extra days. So I just need 7 plus 3. And I know what 7 plus 3 is, and it equals 10.
So he said he knows 7 plus 3 equals 10. How do we know to add though? How do we know not to subtract? Surname?
Because it says and.
It says and is a key word, and it's also saying how many days will she be on vacation, right? We want to know a total. We don't know the total. We're trying to figure it out. So 10 days. Okay, you guys have to do number 8. You are going to circle the hidden information. Remember, it's a word that represents a number. Julie bought a dozen eggs at the market. She gave 3 of them to Serge. How many eggs does Julie have left? Go for it. Circle that information.
Yeah, we know.
Don't forget your labels. Some of you aren't writing equations. That's going to help you remember. Right? And your teachers want to know your thinking. That's how we know you're able to figure out what operation it is by visualizing and looking for clues. All right, let's pick somebody from home to share their thinking. Haley, can you unmute and tell us what the hidden information is?
A dozen is 12. So it's 12 take away 3.
How did you know to subtract?
Because it says Julie bought a dozen of eggs at the market. She gave 3 of them away.
Excellent. Gabe tells you subtract. Okay, how many eggs does she have now?
9.
Excellent. Okay, we're not going to do the others, but I do want to point out the hidden information. So on number 9, does anyone think they know the hidden information? Surname. For number 9? Just glancing at it real quick. If Lisa had 3 quarters and 2 dimes, then she found 3 nickels and 12 pennies. What is the value of the coins and cents she has now? What are some hidden values there? No one? Anybody? I heard pennies. Yep, we need to know that's worth 1. Lila? Quarters, nickels, dimes. A quarter's worth 25. A dime is worth 10, and a nickel is worth 5, right?
Mrs. Alden was here.
Okay. And then the last one, I can't read from there. Can I read yours, Lennox? All right, the last one, Marissa's moving away. She's going to move back in a year and 21 days. How many days will she be gone? Yes, Paxton. A year. We need to know how many, what that is.
12 months.
That 12 months, but is that the question they're asking? What are they asking us? How many what?
Days.
How many days? So we need to know how many days are in a year.
300 something.
364 and a fourth. Is that right, Mrs. Harrison? 365 and a fourth, depending on the leap years. So you need to know that in order to solve that. Otherwise, you can't figure it out. If you're confused on months or days, you got to look back at the text. All right, we're going to look at one more quickly, and this is not quite as common as hidden information. So if we only get through one, we're okay. Last but not least, sometimes we have problems with not enough information. Like, have you ever had someone ask you a question and you're like, I don't know the answer. You're not telling me everything. Like, Mom, do I have enough money to buy this Lego set? And I will say, and I have my $20 from my birthday. I'm like, well, how am I supposed to know? Why would I say, how am I supposed to know, Robert? If you have enough money for that Lego set and you have $20 and that's all you're telling me.
You would say, how much money do you have?
Well, I already know he's got $20. He wants to know if he can buy this Lego set. Will he have enough money? And I say, I don't know. How am I supposed to know? Yeah, say my son comes up to me and says, Mom, and he can't do this now, he's too old, but can I buy this Lego set? Will I have enough money? And he says, I have my $20 for my birthday. And I'm like, well, I don't know.
How much money is the Lego set?
Yes, I don't know unless you tell me how much the Lego set costs, right? So sometimes we get problems with not enough information, like this one. Sarah bought 8 bananas at the fruit market. She put them in a bowl with some oranges. How many pieces of fruit are in the bowl? I don't know. You gotta tell me. I need to know how many oranges are there. All right, let's look at the second one. Let's do this one together. Rebecca did 112 dives in competition last summer. That's a lot of dives. How many of you like to swim? How many of you like to dive off the high dive? How many of you like to flip? Backflip?
I want to.
Oh, you guys are daredevils, not me. I like diving, but I don't like flipping. Oh,
I'm
you
a
guys are
daredevil.
daredevils. Okay, so you're like Rebecca.
I'm a daredevil.
But this summer, she did many more dives in competition. How many competition dives did she do in the 2 summers? Why, Josh? Why don't you know?
You don't know because it doesn't say how many dives she did in a competition.
So I need to know how many more dives she did this summer, right? How many dives did she do this summer? How many dives did she do this summer? That's what I want to know. Okay, you guys try to figure out the next one on your own. Meg bought 3 mystery books and put them on the shelf with her other mystery books. How many mystery books are now on the shelf?
I don't know.
Write down what you need to know. Just do it. Why don't you know? What do you need to know? I notice some of you aren't using capitals, but I am, so you should be. Get in the habit of it. Just because it's math doesn't mean you don't practice our writing. That's a perfect time to practice our writing. Capitals at the beginning of your questions. Here, do your math and we'll get it moving. After everyone goes back, we finish, okay? Good job. So Abby, you might as well keep working now. It's gonna take you a while. You're welcome. Okay. Ellie is ready to share. What do we need to know, Ellie?
How many books were there at the first?
How many books were on the
Shelf at first.
I love that. How many, and I should probably be specific, right, and say mystery books. How many mystery books? And your wording can be different. Don't worry if it's a little different. How many mystery books were on the shelf at first or to begin with? However you want to say it. That's what Ellie came up with. There's no way I can solve that without knowing that. Give me a thumbs up if you did something close to what Ellie did. Kind of close, like you got the gist, same idea? All right. So we looked at 3 different kinds of problems today. We looked at problems that had extra information. Show me how you're feeling about extra information. Oh my gosh. There's so many pages. Extra information is when you don't need it. Okay, what about the ones that had hidden, like dozen or year or week? How do you feel about that kind of problem?
Oh, that's for sure.
Yep, dimes, nickels. All right, last but not least, what about not enough information? Like, what? I don't know. How do you feel about those? Okay. All right, kiddos, we'll keep persevering. Think Central today is 5.6. And I will see you guys manana.
See you, manana.
We'll see you guys soon. Nice job today.